Okay, 7E. So now we're doing a converging lens. Okay, and the P for it is, just to verify, 5 centimeters, the F is 2 centimeters, and the height of the object is 2 centimeters. Okay? So let's draw first. So let's set up our system. Our system needs first a horizontal line to work off of. We then need to build a vertical line. Now as you're considering drawing this on your paper, do, after you get used to it, try to want to consider how much space that you have, so you don't have to redraw, but sometimes you have to. So let's put in our other labels. 5, this is our P distance, 5 centimeters. Our object height is 2 centimeters, so build here. Okay, and then my focus is 2 centimeters. That's my focus. Now for lenses, we are actually going to use both sides. So there's actually 2 foci. We want to use both. And a converging lens looks like that. And again, this drawing right here is only for my mental approach. I'm not using it for anything besides seeing which way will the light bend when it hits it. And so let's start with our diagrams here, our rays. So I have 3 rays I want to draw. Okay? Ray 1 and 2 are the same. Ray 3 we have to change from mirrors. This is the mirror work. And so we can cross that out right now. We're not doing that for mirrors. What we did for mirrors, for lenses. So let's draw our first one. From the object, I want to draw horizontal. Remember, I'm looking at that vertical line. I want to hit that vertical line. Then it's going to bend. Now I have 2 foci to choose from. I could use this one or that one. Now if I look at the lens, which I drew for my mental approach, it's curved down, which means when it hits this should bend and go through down, meaning that I use this focus first. Bam. That is ray 1. Now, rules for lenses. You use both of the foci. So on ray 2, I'm going to go object to the other focus I didn't use. In this case, I didn't use this one. So I'm going to come right through that one first. Remember, I'm using the vertical part of the lens. It's going to pass through, and once it passes through, it's going to go horizontal. Oh, look, these guys crossed. Cool. Now, ray 3 for lenses. So this is for mirrors. Okay. For lenses, it's going to start at my object and go right through the center of the lens. The center of the lens is this point right there. Okay. So as I draw this, I am going to start, you know what, let's do this ray 3 in orange. I haven't done anything else on orange in here, it will show up better. Right about there. Bam, look at that. Beautiful. That is where my image will be. By the way, draw that one with a ruler. That was sloppy. Don't worry, it'll be sloppier when you try to fix it. Okay, that'll work. So, let's start with real or inverted talk. So, is this a real image? Absolutely. It's the real light. Bam. It is upside down, so it is inverted. It's not erect. Q. Okay, let's get a prediction on Q here. That is 2 centimeters. That would be a little over 3.5. Maybe 3.5 exactly. Okay. So I'll say it's about 3.5 for now. And the height of my object is about 1.5. That's the ruler measurement, but I like to verify things. I don't want to put an answer on my final, which is coming up, that's based on what I think it might be. I really would like to have a strong, this is what it is. So let's use Lenz's law for a lens. Makes sense. So 1 over P, so that's 5, plus 1 over Q. So Q is what I'm looking for, is equal to 1 over F. And in this case, what was F? F was 2. Okay? So let's just calculate this out and come back if, am I using the right focus and what would be the negative to it, if there is one. So if I solve this, on, this is 0.5 and this is 0.2, so I get an answer for Q to be 3.3. So how did I know what focus to use? Well, the focus that I'm on is the closest one. That was the utilized focus in this case. So the focus side image, this one is the one that has the real light beams. So this focus in this problem should be positive. If it was this focus on the lens, which would be imaginary because the real light after it hits the lens goes to the right side, then that would be my problem. So my Q is 3.3 centimeters. Okay, that's pretty close. I'd be okay with that graphically. What is the height of my image? I said it was 1.5. Well, let's do magnification. It's negative Q over P. So negative 3.3 over 5. 3.3 divided by 5. So this is going to give me a negative 0.66 for my magnification. Magnification then times 2, which is the height of my object, gives me a height of negative 1.32. Okay, so this was off a little bit. It was a little bit too big, which made this a little bit too big. That would be a reasonable association graphically, but I have the real numbers here that I can verify. I'm good with anything essentially. 1.32, that'd probably be my upper limit. The negative, just so you know, it does go down, but also tells me that's inverted. Couple little tricks. And that's it. Converging lenses. Now, if the focus was outside here, just like I did in mirrors, I would just switch the directions. If I don't have those beams converging together, I would then draw the imaginary on the other side, which is the same rules we're following for mirrors. Good luck.